The next part of integers, the properties. We are going to continue the properties. Okay, are you all ready, children? The first two properties, I think each one of you has understood. The third property is associative property of integers, or we can call it as associative law of integers with respect to addition. Let's see. Here I have taken three integers. Before stating what the property is, you've already done for whole numbers. Now I am doing for integers. Now I have taken 3, -5 and 6. Okay. So 3 plus of -5 plus 6 is 4. What have we done here? 3 plus of -5 is -2. -2 plus 6 is 4. Just recall the operation, children. Nothing is difficult here. These are all the rules that you have already learned. On the other hand, 3 plus -5 plus 6. So how do we operate this? -5 plus 6 is 1. So 3 plus 1 becomes 4. If you observe keenly, what do you think we have done here? What is different from commutative property? Children, can you think? I'm sure all of you must have noticed, because we have done this for whole numbers. Many of you might have recalled what it is. Yes, here we have changed the grouping of the integers. In commutative property, we have changed the order of the integers. That is, if it is a plus b, we have written it as b plus a. The result is same. That is commutative property. Associative property, we have changed the grouping. First I have grouped the two integers and the third integer is written separately. The same integers, I have grouped it as 3 is now out of the brackets. I have grouped 5 and 6, -5 and 6. Still, the answer is same. Therefore, however you group the integers, the answer is the same. This property of addition, this property of integers is called associative property or associative law of integers with respect to addition. I have taken one more example. I have taken all positive integers. Okay? See, this is easy for you to understand. So the same thing, I have given different integers that is positive for you to understand better in case you have a doubt here. Here I have taken 7, 9 and 3, all are positive. First I have grouped 9 and 3. So 9 plus 3 is 12. 12 plus 7 is 19. In the next case, I have grouped 7 and 9 and 3 outside the bracket. So 7 plus 9, how much, children? 16. What is 16 plus 3? Yes, it's 19. So, however you have grouped, we have not taken different integers, the same integers, the grouping is different, that's all. But the result, what is the sum? Sum remains the same. Sum remains unaltered. In general, let us sum it up. Suppose we have a, b and c belonging to set of integers. Okay? Then a plus b plus c is same as a plus b plus c. Again you can see, first I have grouped a plus b. On the right hand side I have grouped b plus c. But the answer, as you have seen in these cases, remains the same. This property is called associative property of integers with respect to addition. Okay, so we can say associative law holds good with respect to addition of integers. Now let's see if it holds good with respect to subtraction. You can see for subtraction, I have taken the example 5, 3 and 2. 5, 3 and 2 are the integers. Now 5 minus 3, we have grouped 5 minus 3 and then minus 2. So what is 5 minus 3? 5 minus 3 is 2, children. So 2 minus 2 is 0. Do you all agree with me? You can work it out and check. 5 minus 3 is 2. 2 minus 2 is 0. On the other hand, now I've grouped 3 and 2. 5 is outside the bracket. So now it is 5 minus 3 minus 2. What is 3 minus 2? It's 1, positive 1. But 5 minus 1 is 4. Children, do you think these two are equal? You have changed the grouping just like we did in addition. Did you get the same answer? As you all can see, you did not get the same answer. We got 0 in one of the grouping. If we change the grouping, then we got 4. So 0 is definitely not equal to 4. So associative law or associative property of integers does not hold good with respect to subtraction. Children, I hope you understood this. We have done closure property, where closure property holds true with respect to both addition and subtraction. Commutative property holds true only with addition. We have seen in the previous session. Now you have learned associative property holds true only with addition, but it does not hold true with respect to subtraction. Is that clear, children? Okay, just make a note. Check the answers. See how this property is different from the previous property, that is closure law and closure property and commutative property. This property is called associative property of integers. So what does associative property of integers say? It states that change in the grouping of integers does not change their sum. That property is called associative property of integers. So we have seen it holds true with respect to addition but not with subtraction. Okay, children, I hope you have noted down the examples also. Keep in mind what the property states so that when I give you homework or assignment, you can recall the property and go about doing your problems. Now, the next property of integers is it's called, if you have done in whole numbers, I'm sure some of you or most of you or all of you must have recalled what it is. Yes, that associative property was the third one. Now the fourth one is additive identity. Children, I hope all of you have recalled what additive identity is. Let's start with examples first. Okay. Now, let's take an example. Minus 5 plus 0. What is minus 5 plus 0? Yes, children, I'm sure all of you have written. The answer is minus Okay? Then 0 plus 28. What is the answer? Yes, it's 28. Next, 0 plus, let's take a negative integer, say minus 59 equals minus 59. Do you all agree, children? Are you able to follow these examples? Next, I am giving you dash plus 1 is 1. Can you tell me what this blank is? Have you tried? Yes, you can see you have added 1 to some integer, but still the answer is the number itself, the integer itself. So what should be this blank? Again, it is 0. So this property, in general we can say, in general, whenever I say general, children, it means we take any variable, say 0 plus m or 0 plus a or 0 plus b, whatever, all those are variables. They can take any integer. So I'll write 0 plus a is same as a plus 0. What is the result, children? It is a. Here a belongs to set of integers. Do you all agree? So when 0, we can sum it up as, when 0 is added to any integer, you get back the same integer that was added to 0. Therefore, 0 is called additive identity of integers, or 0 is called identity element of integers. Okay? Please make a note. When 0 is added to an integer, what happens? Yes, children, when 0 is added to an integer, we get back the same integer. Okay, as we have proved in all these examples. So 0 is called the additive identity. So if I ask you, children, which is the additive identity of integers, you will say it is 0. Why is it called additive identity? Yes, please. So when 0 is added to any integer, you get back the same integer. Okay, when 0 is added to an integer, we get the same integer. So 0 is called the additive identity, or 0 is called identity element of integers. Is that clear, children? Make a note, please. This is fourth property. Additive identity is the fourth property. You can say identity property is also correct, but we simply say additive identity of integers. So if I ask you which is the identity element of integers, you will say 0. How? 0 when added to any integer gives the same integer back to us. So 0 is called the additive identity. Did you make a note? Did you all understand till here, children? So we learned 4 properties. Please try to recall. Closure property, commutative property, associative property, and identity element or additive identity of integers. You have also seen that with respect to subtraction of integers, only closure law holds good. But closure law does not hold, commutative law, associative law, and identity property is not true with respect to subtraction. You can also see if with subtraction it holds good. Let me take an example. So, let's say 9 minus 0. What is 9 minus 0, children? It's 9. Let's say 0 minus 9. Does it give the same result? 0 minus 9. What's happening to 0 minus 9? You are getting negative 9. So, 0 is only additive identity, but it does not hold true with respect to subtraction. Okay? Okay. Next, we move on to multiplication of integers. You will all find multiplication of integers quite easy, children, when compared to addition and subtraction, because in addition you had to learn the rules and then you found that easy, I hope. Okay, but in multiplication, the rules which you have already learnt in addition and subtraction, you will be applying here. I'll tell you how it is. Okay, now the next part is multiplication of integers. Okay, children. In multiplication of integers, before I start that, let's recall what you learnt in subtraction, the rules. You remember these rules, children? Plus into plus equals plus. Do you remember? Can you write the remaining rules on your own? Positive into positive is positive. That means when you multiply two positive integers, you will get the result is also positive. Yes, have you started writing? Negative into negative. Minus of minus. Minus into minus. What is it? It's plus. Next, plus into minus. Yes, children? It's minus. Minus into plus is again minus. I hope you all remembered these. Okay. Now, how are we going to apply these rules in multiplication? Let's see. Now, for examples, let's start in the same order. Let's go in the same order, children. Let me take first example as, say, 9 into 8. Yes, children, both are positive. Positive into positive is positive, your regular multiplication. Okay, so 9 8s 72. 72 is also positive, so the product is also positive. Next, let's take negative integers. Okay, minus 12 into minus 12. Both the integers are now negative. The second rule, minus into minus. Minus into minus, children. Here you can multiply these signs because the sign inside inserted is multiplication. So minus 12 into minus 12. What we do is, first we multiply the signs. Minus into minus is plus. Even if we don't write this, doesn't matter. 12 into 12, children, 144. So positive integers, when multiplied, you get positive answers. Product of two negative integers is again positive. Now I'll take one positive and the other one negative integer. Let's see. So 14 into minus 10. One is positive, the other one is negative. So plus into minus into, multiplication sign, children. Plus into minus is minus. 14 into 10 is 140. Is it clear to you? First, multiply the signs using these rules. Then multiply the integers forgetting the signs. Because already you have operated the signs, now you don't have to worry about the signs. Multiply the integers. Multiply the numbers. Okay. So, third condition. Fourth one, let's take one negative integer, the other one is positive. So, minus 2 into, say, plus 45. Minus into sign, minus into plus is minus. 2 into 45 is 90. Children, did you all understand? I've applied same rules and this is the operation and these are the products. How? You have seen the first case, it is positive integers, product of two positive integers. Then we have product of two negative integers. Then we have product of integers with unlike signs. You remember what unlike signs are? Yes. They have different signs. That is, one is positive, the other one is negative. So far, did you understand, children? So we can sum it up as A into B. See, both are positive. Is positive A into B. Please make a note. Here A and B are integers. They are variables, children, meaning they can take any value, any integer they can represent. Okay. Then we have both are positive. Now we are taking both negative. Minus A into minus B is, what is minus into minus? It's plus, isn't it? So plus A into B. First, take care of the signs. Multiply the signs using these rules. Then multiply the integers. Next we have A positive into negative B. So plus into minus is minus. Again A into B. Again A and B are integers. Next we have negative A into positive B. Again minus into plus is minus A into B. Children, did you all understand? Didn't you find it easy when compared to addition and subtraction? Of course, addition and subtraction is now easy for you because now you have learned the rules, you have done many problems and now you are thorough, I hope. I'm sure you're all. And then we come to multiplication of integers. You find it easy when compared to the previous two operations. Okay, because these rules are simple, very easy for you to remember. Clear, children? Now, I'm going to give you some examples. Can you solve right now? Will you try? Please try. Minus 2 into minus 9 into minus 1. Keep trying I'll give you more examples. Minus 15 into 30. Try. Next. I'll give you one interesting problem, children. You will like it. You have to think a little. It's not difficult. Minus 1 into minus 1 into, say, 50 times. Okay? Think of the answer. Next one. Minus 1 into minus 1. 99 times. Please think. Think of the answer, children. Did you get the answer? Now here you learn for two integers. Same rule apply for 3 or 4 or 5, any number of integers. Okay. Now here. First multiply, first take care of the signs we discussed, is it not? So, minus into minus is plus. Do you agree? Then plus into minus. The final sign is minus. How did we get? Minus into minus is plus. If you get confused, please group. No problem. Minus into minus is plus. Plus into minus is minus. So the final sign is minus. Next, 2 into 9. What is 2 into 9? 18. Because 18 into 1 is 18. Next problem. One is negative. One is negative. The other one is positive. Okay. So, minus into plus is minus. 15 into 3 is 45, children. Followed by 0. Look at this. It's very interesting, children. Minus 1 into minus 1 and so on 50 times. This 50 is even. When you have even negative signs, finally your sign in the answer will be positive. Because minus into minus is plus, like that you have even number. So when even negatives are there, your final sign will be positive. And what do you think the answer is? Is it 50? Many would have written 50 by now, I'm sure. No? Okay. It is 1. Is it not? 1 into 1, 1. 1 into 1, 1. Okay. So the result is 1. Now look at this. Minus 1, minus 1, minus 1. 99 times, but 99 is odd. So one negative sign will be left. So all become positive. One negative sign is left behind. So plus into minus becomes minus. And sorry, the answer is 1. Clear, children? Minus 1 like that. Odd number of times the result is negative 1. And not negative 99, children. It is negative 1. Okay. I'm sure so far this you have understood multiplication of integers, children. Now look at the assignment for your work at home. Yes, please. Very simple. What I've given is all the properties, children. You have to fill up and mention the property. So see, one is, you might have already found the answer here and the property, I'm sure. Here also dash plus 59. all these properties you've already learned. So I've given all the properties. Try to fill up and identify what each property is. Here I've given something for you to think. You have to think a pair of integers where write a pair of negative integers whose difference is 8 and write a pair of negative integers whose sum is negative 45. Please think. I'm sure all of you can do this. We are anyway going to discuss in the next class, but please try it, think and do it. Now here I've given find the product of, okay. So all these try to find out. Now I'm already in the example I've given 99 times. So I'll change this. I'll make it, shall I make it 500 times? Okay. So think, okay. Do the homework, children, and we'll meet in the next class. Thank you very much. Take care. Please eat nutritious food, children, and practice yoga which has been taught to you at school. Be safe, be at home, be happy. Thank you.